Okay, I just figured out how to cut and paste a picture from Microsoft Word into here, so I am officially now in feeling awesome. So anyway, this problem, this is it's sad what makes me feel this good. All right, anyway, this is problem 8, and what we need to do here, the question is basically this switch gets closed, okay, so switch gets closed, so you can pretty much just ignore that, and the battery charges up the capacitors and is allowed to go for a long time, they say. And what that really means is that they just let the capacitors reach full charge. Okay, and then we're supposed to find the voltage across each capacitor. Okay, so first of all, let's look at an equivalent capacitance for the whole thing. So let's look at, should we? Yeah, let's do that. So if we look at an equivalent capacitance for the whole thing, here is our, I'm just going to redraw the whole circuit, or try to. Okay, so the first thing we want to do is we want to take the sort of the smallest unit we can and chunk it together. And so the smallest unit we can do with this is these two that are in parallel, right? Because they're in parallel, and then this unit is in series with this guy. So we want to handle these two first. So we have these two in parallel, and the rule for parallel capacitors is you simply add up the capacitance. Okay, so the equivalent circuit here still has C1 up here, and then this guy down here is C2 plus C3, which is 30 microfarads. Okay, and then C1 is of course still 10 microfarads. Wait a minute. Oh, 20. There we go. 20 microfarads. Okay, and your voltage is still V, of course, blah blah blah. Okay, so there we go. Now the next step, I think, if we want to figure out what's going on here, is to just put these guys together into one equivalent capacitance, I think. Yeah, that's the way to go. Okay, so I'm going to take them and turn it into one even, more all-encompassing capacitor. Okay, this guy. And the rule now, when we have two capacitors in series, is that the capacitance there. So I'm going to call this guy I'm going to call it C123. Okay, so C123, you get the reciprocal of C123 from the reciprocal by adding the reciprocals of the two in series. So the reciprocal of C1 is 1 over C1, and the other guy is 1 over C2 plus C3, but we already had that, right? So, I mean, we already know the value of C2 plus C3. I'm just writing that down to keep it nice and symbolic. So 1 over C123 equals 1 over 20 microfarads plus 1 over 30 microfarads. Okay, so it's all our fractions and common denominator stuff from, what was this, like 6th grade we learned? No, 4th grade, I think. Okay, anyway, whenever it was. So this becomes 3 over 60 microfarads, because our common denominator is 60, plus 2 over 60 microfarads. God, this is my Friday night. I can't believe it. All right, and so that's going to equal 5 over, no, not 12. Well, I'm jumping ahead. Okay, 5 over 60 microfarads, which is 1 over 12 microfarads. So C123 equals 12 microfarads. Hope that's not off the screen. Okay, so that gets us that, and we still have a voltage of 5, of course. So yeah, there we go. And so the voltage there is still 5 volts. And what I'm going to do, I think now that I've figured out my equivalent capacitance, I'm going to ax this and then start calculating charge. So charge, then, of course we develop some charge on this capacitor, okay, Q, and we just use Q equals CV. So the charge on 1, 2, 3, I'm going to call this Q123 equals, so this will be Q123, will be equal to C123 times the voltage applied, which is this 5 volts, and that is going to be 12 micro times 5 is going to be 60 micro, and a farad times a volt is a coulomb. Okay, which gets us charge, of course, so that's all good. Okay, so that's Q123. Now, when you have two capacitors in series, how does the charge distribute between them? And it's actually kind of a trick question, because in fact they're both going to have the same charge as they're both going to have the same charge, and it's going to be equal to the charge on Q123. So if I keep writing Q123, what it means is this guy is Q123 and this guy is Q123. And that makes sense if you think about it as though this guy here, C123, is supposed to be equivalent to these two together. And so this top plate really here has to act like the top plate of C1, and the bottom plate of this guy has to act like the bottom plate of the C2 plus C3 equivalent. So that means this guy has to have plus Q123 on top, this guy has to have minus Q123 on top, which means they also have to have the matching charges on the inside, so they both have to have the same charge. Okay, so now we can find the voltage drop across 1, and that was part of our problem. Okay, so this here, we can say this is V1, which is the voltage change across 1. And so V1 is going to be, well, let's see, so we take this guy, I mean, it's this equation here, right, that we're going to take, and we're going to turn it into Q123 over C1. And so Q123 is 60 microcoulombs, C1 was 20 microfarads, and this is going to equal 3 volts. So that is going to be V1. Okay? And now here's the interesting thing. First of all, V1, and then what I'm going to call V23 for the voltage across these 2 and 3. V23 and V1 have to add up to V, right, which is the battery voltage. If you have a voltage change going from here up to here, and then another voltage change from here up to here, that's got to equal the total voltage change from here to here. That's kind of obvious. So really what you can say then is V2 equals the battery voltage, which I guess we're calling V. So this is kind of not too great notation. But V2 is going to, actually that's V23 I mean, but we'll see something else in a minute. V23 is just going to be 2 volts. And here's the thing. We don't actually have to do anything more now, because the voltage, what we found, this voltage 2,3 across this parallel pair, well, that's also the voltage across each of these two guys, right? Because if they're in parallel, they're going to have the same voltage. And, we're just finding the difference between the voltage here and the voltage here. That's this and this, right? And so, kind of obviously, this is going to be V2 and V3, because they're both going to have the same voltage. And so there is your answer to problem 8.